What is sequential access? Sequential access is a system by which stored data is accessed in a fixed order. One example of this is an audio or video cassette. The most common use of this system is in computer memory, where it contrasts with the more widely used random access memory. The phrase sequential access simply refers to the fixed order of access. As well as being fixed, this order is predetermined and follows a logical progression. Some types of sequential access are unavoidable, such as when playing back a cassette. Other types are a deliberate choice. This can include computer data stored as a linked list, in which each piece of data contains a reference to the following piece. Sequential access memory is a storage system where the data is stored and read in a fixed order. This contrasts with random access memory, such as that used by computers for storing data to be processed. As a rule of thumb, sequential access is the type of memory more likely to be used for permanent storage and random access memory for temporary storage. Examples of sequential access memory include older recordable media such as DVDs, CDs, and even tapes. Hard drives are also sequential, rather than random access memory. Random access memory included memory chips found in computers, as well as flash memory that can be fixed inside a device or removable, such as memory sticks or memory cards. The main advantage of sequential, as opposed to random access memory, is that it is usually much cheaper to produce. This also makes it possible to get more data capacity given both a set price and a set physical size limit. Sequential access memory is also more commonly used in physical storage forms that are less susceptible to physical damage, including from electrical surges or power loss. The main drawback of this type of memory is that it usually takes longer to physically access any one piece of data. This is because the computer either has to run through all the data in order until it finds the correct piece, like looking for information in a book with no index, or it has to use a seek function that knows where the data is stored but still needs to physically move to the relevant section of the storage device. In contrast, random access memory is set up so that it usually takes an identical time to find any individual piece of data.